Subscribe to our YouTube channel and press the bell icon to get the latest updates.
Everything our eyes can see, from a tiny ant to massive galaxies, make up less than 5% of this universe. The rest of the universe is a mystery, invisible to the naked eye as well as to the most advanced telescopes we have. About 27% of the universe is dark matter, the invisible force holding galaxies and the cosmic web together, while 68% is dark energy, which causes the universe to expand at an accelerated rate. World over, physicists have designed massive instruments and experiments aimed at detecting the mysterious dark matter and dark energy. But now, a team of scientists at the University of Cambridge suggests that we may have already made the first detection of dark energy about a year ago. In this video, I'll explain what dark matter and dark energy is, how we even know that they exist, and why scientists think that they may have detected dark energy already. I am Mohana Basu and this is Pure Science. The first clue to the existence of dark matter came in 1933. Swiss-American astronomer Fritz Zwicky was making estimates of the mass of all the stars in what is known as the coma cluster of galaxies. Now, Newton's law of universal gravitation states that any two objects will have a force of gravitation between them. This force is defined by the following formula, where F is the force, m1 and m2 are the masses of the two objects, and r is the distance between them. G is known as the gravitational constant. So according to this law, the force between any two objects is directly proportional to the product of the masses of the two bodies and inversely proportional to the square of the distance between them. Using these laws, Zwicky realized that the mass of the stars in what is known as coma cluster of galaxies is only about 1% of the mass needed to keep the galaxies from escaping the cluster's gravitational pull. This missing mass remained a glaring question mark for decades, until the 1970s, when American astronomers Vera Rubin and V. Kent Ford confirmed the existence of dark matter by observing a similar phenomenon. The mass of the stars visible within a typical galaxy is only about 10% of that required to keep those stars orbiting the galaxy's center. This meant that there was some other mass that was keeping our universe held together. But since this mass is not visible, it came to be known as dark matter. Since then, scientists have determined that matter is 30.6% of the universe's composition, while the rest of the universe is composed of energy. Only 0.5% is in the mass of stars, and 0.03% of that matter is in the form of elements heavier than hydrogen. The rest is dark matter. Dark energy was even more mysterious. Our universe has been expanding ever since the Big Bang, and earlier scientists had assumed that the attractive force of gravity would slow down the expansion of the universe over time. But then scientists found that instead of slowing down, the expansion was actually speeding up. Dark energy is thought to exert a repelling force in the universe, driving the acceleration of the expansion of the universe. Now, in a new study, scientists from the University of Cambridge, who are part of the Xenon 1T experiment deep below Italy's Apennine mountain, propose that they may actually have detected dark energy. The Xenon 1T experiment is basically aimed at looking for dark matter. It is essentially a huge cylinder full of 3,500 kilograms of colorless, dense, odorless element known as xenon in the liquid state. About 62 kg of this xenon exists on the surface of the liquid xenon in a dual state. That is, it fluctuates between liquid and gas. Any interaction with any particle in this region of xenon produces a flash of light that gets recorded by sophisticated detectors at the top and the bottom of the chamber. Every interaction also knocks off some electrons, which, as you must be aware, are the negatively charged fundamental particles that are present in every element. There is an electric field applied to the chamber which causes these electrons to drift off slowly. These also create flashes of light that are noted by the photodetectors. Now, the delay in the initial flash of the light and the subsequent ones can be used to pinpoint where the interaction occurred and what type of particle interacted with xenon. Now, about a year ago, the Xenon 1T experiment reported an unexpected signal over the expected background. At the time, scientists had hypothesized that this signal was due to axions, which are hypothetical, extremely light particles thought to be produced in the sun. However, scientists later found that the amount of axions that would be required to explain the Xenon 1T signal would drastically alter what we know about the evolution of stars, which are much heavier than the sun, and would not agree with what scientists observe in our cosmos. So, the Cambridge researchers constructed a physical model to show that dark energy particles produced in the sun's strong magnetic fields could explain what was detected by Xenon 1T experiment about a year ago. Researchers used their model to show what would happen in the detector if the dark energy was produced in a particular region of the sun called the tachocline, where the magnetic fields are particularly strong. They concluded that in principle the signal could have been caused by dark energy rather than dark matter. Their calculations suggest that experiments like Xenon 1T, which are designed to detect dark matter, could also be used to detect dark energy. However, there is still a lot to be done before we can say for sure that dark energy has in fact been detected. For instance, the scientists still need to confirm that this blip was not simply a fluke. If Xenon 1T actually detected dark energy, we can expect to see a similar signal again in future experiments. So the team is now eagerly working on upgrades to the Xenon 1T experiment that could possibly directly detect dark energy within the next decade. Lux Zeppelin, or LZ, is a next generation dark matter experiment funded by the US Department of Energy, and the Panda XXT in China are similar experiments which could also end up detecting dark energy if the Cambridge researchers' theory is indeed correct. Detection of dark energy holds the key to better understanding our entire universe, and that is why some of the most brilliant minds across the world are working towards unraveling this mystery. This is Mohana Basu, special correspondent at ThePrint. If you like our videos, you can now join ThePrint's YouTube membership to get special membership perks such as early access to our key reports as well as exclusive community content on the YouTube channel. You can do so through the link in the description box below.